So, can you tell us more about who you are?
Yes, my name is Luis Cia. I work as an assistant research professor and a researcher at the University of Colorado Boulder, specifically in a research center called Space Technologies. And we support scientists in having their scientific experiments performed on the International Space Station.
So, why did you want to become an aerospace engineer?
It's one of those things that you already know. It's kind of like if you're into strawberry ice cream, somebody says ice cream, and the one thing you think of is strawberry ice cream. That's kind of like the way it was already inside my head since I can remember. So I've wanted to be part of, humans' endeavor to explore space, and aerospace engineering was the way that I found out that I could do that. I didn't know aerospace engineer was a thing until I was in high school and I was watching a show on Discovery Channel back in the day when they actually had science on Discovery Channel. And they're interviewing, I think it was a JPL aerospace engineer in charge of one of a spacecraft going to Mars or Jupiter or something. And it was the name, and under the name it said aerospace engineer. And I was like, I didn't know that was a thing. Like I didn't know that existed. So I'm from Guatemala, and there's no such thing as aerospace engineering degrees there. And it was pretty. So I looked for scholarships and other ways to go somewhere where aerospace engineering existed as a degree. It took me a while, so in addition, so what I did is I did an undergrad in mechanical engineering because that was the closest thing I could find, knowing that having a degree in mechanical engineering makes the transition into a master's in aerospace engineering possible because they have so much overlap. But because I didn't know if I was going to be able to come to the States and be part of this, I studied German from 6:30 in the morning until 8 in the morning, 5 days a week for 2 years, because my plan B was to go to Germany or apply to schools in Germany if I couldn't make it into the US. And later, I learned Portuguese during my lunch breaks as a plan C. If I couldn't come to the States or go to Europe, I was going to try to go to Brazil for a degree in aerospace engineering. So I've known always that, well, I didn't know exactly what in aerospace engineering would I like to do. I knew that I wanted to be part of it. And fortunately, that's what I'm doing now.
So, can you tell us about bioastronautics?
Absolutely. Bioastronautics, in short, it's the study and support of life in space. So it's different from astrobiology, where they're trying to understand potential sources, the origin of life, and where else may life exist outside Earth and in which forms. Bioastronautics is more of the study of Earth life in space. So, for example, we bring cells or organisms or even the human, the human organism, human beings as what is being studied in space in terms of what are the effects of microgravity, what are the effects of radiation on say, the eye, the heart, or bacteria. Bacteria behave differently in some cases in space. And then the part of support of life in space is imagine all the systems that you need to have in a spacecraft or a space station to make sure that the humans are going to be alive and healthy and happy. Those are the three key parts. Alive, you want to make sure that you remove carbon dioxide, you provide them with oxygen to be within a range of temperature, within a range of humidity, and that comes to the part of healthy and happy too, right? You wouldn't want to live probably in 100% relative humidity, super hot environment for weeks, right? That would just be suffocating, like being in a sauna. So you, as an engineer, need to produce these systems, to design and develop them, test them, and then once they're in space, operate them. So that's the part of support of life in space. So that also involves the design of the habitats and the spacecraft. And that's pretty cool, right? So it's like, what do you want to do when you grow up? Oh, well, I want to design spacecraft. Well, aerospace engineering can help you get there, and specifically a bioastronautic focus can help you get involved with that. For example, the kind of courses that you get here at the University of Colorado when you're doing grad school in aerospace with a focus on bioastronautics include space habitat design, space life systems, space life sciences, sorry, or extravehicular activity suits, EVA suits. A lot of cool stuff like that.
So aerospace engineering have different specializations and everything. Why'd you choose to specialize in bioastronautics?
Because my intention is to that the work that I do helps enable a safe exploration of space. And there are a lot of risks that are being monitored. For example, what's going to happen to the human body as it is exposed to deep space radiation on a long-term travel to Mars, or what are the effects on the human body and the other things that affect us, like bacteria and fungi, once they're exposed in microgravity. Something some people don't know is that inside and on our bodies, there are more bacterial cells than our own cells. So it doesn't matter how well you clean a spacecraft and everything that's in it, wherever humans go, bacteria and fungi are going to go as well, because they just live in and on us. So whenever there are changes on these microbes, these changes can have an effect on the human body and the human health. So that's something else of interest of studying to make sure we can have safe exploration of space.
Mhm. So you've been also involved in various experiments in space. So could you tell us about one of them?
Yeah, one is we're preparing with a team of engineers and scientists here at the University of Colorado in Bioserve, at the University of British Columbia, at the Deutsches Luft- und Raumfahrtzentrum, which is the German equivalent of NASA, the German Aerospace Center, Universidad del Valle de Guatemala, which is a university in Guatemala, and MIT, a project called Deep Space Radiation Genomics. And that one is going to go around the moon on Artemis 1, which is the upcoming NASA mission to go around the moon, scheduled to launch, I believe, late this year or early next year. And that one, we're using yeast, the same thing that is made, is used for making bread, because there are a lot of genes in yeast that have homologs, have equivalents on the human DNA, on the human genome. And then you cannot really fly, 100,000 or a few million humans and see, like, study what happens here and there, but you can fly hundreds of thousands and millions of yeast cells and assess the effects that deep space radiation and microgravity have on their survival, or their ability to survive these conditions, as well as what kind of genes they're encoding, they're expressing to encode for proteins, etc.
So what has also been one of your most difficult projects so far?
They are all difficult in one way or the other, and that's the thing. There was this really cool study, and I can't remember where did it come out. I think it was on a Time magazine or a Newsweek or something, where they did a survey of how satisfied people are with their jobs, and the number one profession where people were the happiest doing what they did was aerospace engineering.
Mhm.
It's just that people who get into this, I think we're all very passionate about space. Like, I'm working all day long on space stuff, and then when I have some free time, I listen to space podcasts, or if I'm going to watch a movie, I love watching space movies. It's just something that usually we're pretty passionate about. So that's something that keeps you moving. But one thing about aerospace engineering is that usually, not always, but a lot of times, you work on R&D, on research and development. And that means that you try doing something new for the first time. And that has a lot of challenges, to which it's not like you can Google, how do you make this pump operate at this flow rate and microgravity while blah, blah, blah. It's things that you have to come up with ideas together with your team and test them. And most times it doesn't work. So you tweak your idea or try completely new things and test again until you find an answer. So yeah, we have that challenge with all projects. So I wouldn't say just one, but it's a general thing.
So you also been selected as one of the most influential people in Central America by Forbes magazine. How did you accomplish such a thing?
That was totally out of the blue. Like, someone just like tagged me on Facebook once that came out. I was like, what? So my hypothesis of how that happened is that they had somebody on the spot, like, hey, we need an article in 3 hours. So, like, put up whatever you can. and they Googled. I do a lot of STEM outreach, and especially even more so before. So I give talks and I give workshops and trainings and that kind of stuff. So I guess my name just came up on those things. I really don't know what was the criteria they used. Probably somebody had lack of sleep or something when they did that.
So what is something that you regret not doing at the beginning?
Mm, I don't think I have any of those regrets. If anything, would be the opposite in terms of getting towards what I wanted to be in aerospace engineering. Now that I see in retrospective, I've had a poor life-work balance, and I think it's part of how passionate I'm about the topic. So if I would do something different, I would probably give myself some more time to do stuff that is not, professional career.
Mhm. So what do you think is going to be one of the next biggest discovery or innovation in aerospace industry?
Lots, but for sure, reusable flights. That's a game changer. Once that becomes more commonplace, I think we're gonna see prices drop and for bringing mass to orbit. And I think that's gonna trickle down to more companies doing operations and providing services and goods from space. So I think that's one thing that's game changing, and just the fact that now NASA has this push with the Artemis program to go to the moon. I think that's something we had not seen with the kind of political support that it has since Apollo. So I think that's game changing. We live in a very exciting time, I think.
So to high schoolers like me and to younger folks out there, what would your advice be to um what would your advice be for us to be successful in this aerospace engineering?
So, this is gonna sound very like, oh, that's what my mom says, or that's what my dad says. But good grades. Like I never really understood. I just thought like when my parents were telling me you need to get good grades, I thought they were just like I was like coming in and coming out this way. But now I know after struggling to get into the aerospace industry coming from Guatemala, like I said, after high school, I tried to study aerospace and I couldn't find scholarships that would support me as an undergrad. And then after I finished my undergrad, it took me a couple of years to be able to come to the States because it's very competitive. Grading system is different. There's a lot of things, but but for sure, I'd say mm, good the way I see it now is that good grades are a key to open doors to where you want to go and to other places you hadn't even imagined. So if I had had better grades in high school, the chances of me finding a scholarship to come and work in aerospace sooner could have been higher. And then the other thing is, so and then don't get too focused like or solely focused on grades. There are other things that are also taken into consideration when you're applying to schools by professors who may take you in their research groups. One is ability to do research by your own. So you want to show extracurricular activities and interest in the field. For example, either join a student group that's related with space, or if there's none in your school, start one. Um, uh, if for example, topic X is what you're interested in, say electric thrusters, right, or electrothermal thrusters, for example, that's the thing that you're passionate about. Then do research about it every time you have a chance of doing like a project in any class where you have freedom to choose the topic. Go for it. Include that in your CV. That will help you demonstrate your interest. And volunteering work, that's something I personally think is pretty important. Uh, regardless of our origin and the things that we have had to live, we're very fortunate compared to so many other people. So I think it's always good to try to help others in any way we can. Maybe you name it, right? There's so many volunteering opportunities that's something that may be considered.
So in bioastronautics, which innovation are you looking forward to?
Um, space biomining, or biology-based in situ resource utilization. So here we have a project, and other teams around the world have projects looking into using bacteria to extract resources from lunar, Martian, and asteroid dust, the regolith. And it's a win-win-win kind of situation. If you find the right combination of bacterial species or microbial species and the type of regolith, the type of dust, then it's a win for the organism because you're providing it with something they want or need. It's a win for you because basically the way you can see it is that the bacterium comes and eats something that it's present in the regolith, and it poops away something that is of your interest. So I'll give you an example of research we're doing here. We're using an organism called Shewanella onedensis, that what it can do is it transfers one electron from one place to the other, and it uses iron that is present in the lunar dust or lunar dust simulant. So the dust has iron in it, but it's integrated into the whole into the whole regolith in a way that it's really hard to separate. If you want to do this through physical chemical process, you will require a lot of energy to be able to separate that iron. But if you combine that with this organism or other organisms, what they do is they transfer an electron. Basically, they're doing their metabolic processes. And by transferring this electron, that iron that is inside the rock now it just solubilizes. It goes into the liquid. And then you can use other process, for example, a magnetic process, to separate that iron from that combination of your bacterial culture and the regolith. And now imagine that you have a bioreactor on the lunar surface, and you have this regolith, and you have your bacterial culture. Just let it sit, and then you have this magnetic process where you're separating the iron that the organism is producing as it's happily eating the dust, so to speak. And now you can feed 3D printers, for example, and you can build structures in situ, in the location you are in. And you don't need imports from Earth to build things. And this is something that's already done on Earth. It sounds super sci-fi, but it's already done on Earth. 5% of the gold and 15% of the copper that is currently on the market comes from a process that includes biomining. So now the question is, how do we learn from those processes and implement them in space so that it can help human establishment in space to be more independent?
So I don't have any more questions. Is there anything that you would like to add?
Yeah, the road is definitely going to get rough, not a couple of times, a lot of times. And perseverance is super important to both have your long-term vision always in place. And second, and this is probably the key part, is having a roadmap. Have a map of how do you want to go from where you are to that point. And finally, know that that long-term vision is going to change and is going to evolve with time. And you got to keep growing. I personally think that if one stays in their zone of comfort for too long, like, okay, I'm really good at doing this process, I'm not going to try this other thing that is new because, I don't know, maybe I'm going to fail. With that mentality, it's hard to keep expanding and growing professionally. So leaving that zone of comfort to try new things. And finally, we usually think of the degree we get at a university as, this is it. It's a brand that I have on, and this is the one thing I'm going to do for the rest of my life. And professional development is not a straight line. It's like this. You're going to be trying different things, seeing what you like, what you don't. And don't see your degree, may it be aerospace engineer or otherwise, as something that should limit you in terms of what you can and can't do. See your degree as some sort of license that allows you to do something that certifies to an employer that you can do that. But that doesn't mean that you're not capable of doing other things. So, like, as an example, I'm an aerospace engineer, and I've been working as a microbiologist for over 10 years. So what I do now is microbiology, talking about bugs, removing iron from regolith. If you keep an open mind in terms of that you are capable of doing things other than what normally that degree does, then you're going to be able to be way more powerful in terms of what you can produce as a professional.
All right, well, thank you for giving me the chance to interview you, and that was it. And stay.
Awesome. Very cool, Valerie. So now question